Hi guys, in this video we're going to be having a look at the dictionary abstract data type, and we'll be going through a few problems and implementations to have a look at how they work. We'll be doing that with the use of tomatoes and different vegetables from my garden. I hope you guys like the video. Let's get into it.
Welcome back, guys. We're going to be reviewing dictionaries today. So, what is a dictionary? Just to refresh, dictionaries are an abstract data type which store values under a unique key to access them. So here we've got values and they're stored under key 1 and key 2 within this dictionary. So, there's more structure than a list or a similar ADT because of this. And you'll also realize later down that unlike other ADTs, such as queues, etc., there's no... Python actually has built-in functionality for them. So, keys within a dictionary must be unique, unlike lists, and this is because the keys are used to access the value stored within them. So if I asked for key 1 and there was multiple key 1s, then it wouldn't know which value to give me. So each key within that one dictionary has to be unique. So, they're also very useful for storing related information, as we'll see in a moment. So I want to store information about my tomatoes, so I have the correct information and I can access it very easily. So, what I've gotten for this is I've made a dictionary called tomatoes, and within that dictionary I've stored keys for the related information that I think would be really useful to know. So the season that they grow in, the sowing season, the spacing, a part of the tomatoes, are the three things that I've added right now. And the values that I've added for them is the season would be summer, the sowing season would be spring, and the spacing would be 50 centimeters. So now that I've stored this vital information, I can access it much easier. Let's have a look at some pseudocode for doing this. So, defining the dictionary, just as on the last one, season summer, so spring spacing 50. You'll notice that you want to use the curly brackets on the outside and the same structure that we've just discussed with colons, commas, to separate the different values and the keys. So, to check the season to sow, we can look up the sow in tomato. And if we want to display something that we're looking up, then we can print. So if we print season in tomato, what it should give us is summer as an output. If we're going to use if statement, say I want to check the length of my dictionary, I can check if tomato length is 3. Now, as you'll notice, we're actually checking the length of each pair of key and value. So in this case, it would be 3. So doing that, we're going to print missing key because let's say we actually want 4 values. So I've said print missing key if the tomato length is 3. So what are we going to add in as that missing key? I'm going to update tomato with water daily, and that should add an extra value into there, and then we can print the dictionary, just print tomato. Let's have a look at doing this in Python. Very similar for defining the dictionary. We've just got a little bit more grammar with the quotation marks around season and summer, for example, which pseudocode would be a lot less strict on. So if we're checking the season to sow using a lookup, then we go tomato.get and then in brackets sow. So this is specific to dictionaries. This will get the sow within tomato and give you the value associated with that key. So if we're going to print a lookup, then we can go print tomato.get season, and we'll see in a second what that gives us. Using an if statement to check the dictionary length. So we go if length of tomato, again, double equal sign is equal to 3, and we use len for length for that. That's the grammar for that one. And print missing key just on the last one. And then tomato water daily is how we add an extra value. So tomato square bracket, and then for the keys, we store the key in the square bracket and then equal to the value. If we print the dictionary, we can just print tomato. Very simple for that one. This is the output we get. So we printed the tomato season. That printed us summer, which is correct. We've printed missing key as here. And then season, summer, so spring is the whole of tomato. And you can see now that water daily has been added there. And again, water's the key and daily is the value for that. SnapApp's edgy is a little bit different than Python, but again, we have to set the tomato variable before we start and then make that equal to the dictionary here. And if you wanted to add more values to that, you can actually just press the arrows and it does let you add more values to enter there. So I've wrote think, get, so, and dictionary tomato, and that should that's how you would get the value in there. And then if you say get season in dictionary tomato is how you would get the season. If the length of dictionary tomato is equal to 3, so this is how you do an if statement. Very similar. Again, less grammar rules in Snap Apps because you are just dragging things. You don't have to remember that as much. And then set water in dictionary tomato to daily is how you would add another value. So again, if we print out that new dictionary, then we're going to get season summer, so spring, spacing 50, and water daily. It also gives you the length down here, which is really helpful. So let's do something a little more complicated. Let's look at a dictionary of dictionaries. So this is a nested dictionary. So on the outside, we've got plants is equal to, so this is our larger dictionary. And within that, I'd like to store information about more than one plant in my garden. So in this case, I've got tomato, classic tomato. I've got cucumber. I've got peas. And I've got lettuce and carrots. So in this case, you'll notice first of all, yes, the keys are repeating. The season keys here, source keys and spacing keys are repeating. They can repeat because they are in different dictionaries. If I had tomato, 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 that would be an issue, but because the season is within different dictionaries here, that's not going to be an issue when we're looking up. So there's no problems there. You'll also notice instead of tomato is equal to, we've got tomato colon, which means tomato itself is now a key, cucumber's a key, peas are a key, and the value that is stored in them is the dictionary. That's just a different way of doing it. In a nested dictionary, if I wrote equals, then I guess it wouldn't really be a nested dictionary, it would be a list of dictionaries. So that's just how you do a dictionary of dictionaries. So there's a little bit different grammar if we want to print something within there. So if I'm looking up the sowing time for peas, we're going within plants, within peas, within sow, and that should give us autumn. So print sow within peas within plants would be one way of doing that. So we're printing the sow within peas within plants. Alternatively, a little bit more like Python, you could go print plants, square brackets, peas, square brackets, sow. And that will go within plants, within peas, within sow. And Python, again, very similar implementation. We're just using quotes, again, around all of the values that aren't numbers. And we're going print, plants, peas, sow, very similar to that second grammar there, that second option for pseudocode. It's really up to you how you do pseudocode. So many different possibilities, and there's not many rules, which makes it really fantastic. Okay, so that's pretty much everything we've covered.
So we just had a look at how dictionaries work. We looked at them in an example using plants from my gardens, and then we had a look at how that would work in pseudocode, in Python, and in Snap Apps Edgy, and a more advanced example of dictionary of dictionaries.